Good morning. Welcome to lecture number 4 for ED 200. So I hope everybody is doing well, right? Are there any comments on the module so far? Is it manageable? Everything okay? Right? You can type in the chat group. Okay, I hope all of you are coping well. And do take note that this coming Friday will be your first quiz, right? It will be a closed book. Then what will happen is I will be providing every single one of you with maybe a A4 paper, right, for you to do your working. So it'll be closed book, and there isn't much to remember. And don't worry, I'm not going to test you on the SQ table. There's no point. Okay, so like I mentioned before, if I'm going to test you on the SQ table, then the table will be given to you. Okay, so don't worry so much about the SQ table. Right. Now, we are going to start on Boolean algebra, right? So this is going to be again a big part of the midterms, right? So midterms, you'll be asked to simplify circuits, right? So you'll be given like some Boolean function, and you'll be asked to simplify, or maybe given a circuit, you're supposed to come up with the Boolean function itself, right? So I believe some of you will like this part, right? Because there's a lot of like things like logic and and a bit of detective work here and there, right? Now the thing here is that for logic functions, right? We always require you to come up with the most optimal, right? The most optimal. So example, if a function we ask you to simplify, right? You did not get the simplest form, right? So there will be some marks deducted, maybe 1 or 2 marks deducted. Okay, but if you can do the simplification using the rules, then you should get the bulk of the mark. Okay, there's a question. Do we need to bring laptop for the quiz? Yes, you need to bring. Okay, so it will be conducted during the tutorial session. Okay, now, okay, so we are going to talk about the laws and rules of Boolean algebra. We're going to start with some basic stuff, right? So again, do remember some things that we went through in the last session, right? We have a dot, like A dot B means A and B. A plus B, we call this A or B. Okay, now, so what we're going to do is we're going to look through the rules, right? We're going to look through the rules and write down what is equivalent form. Okay, so let's talk about x and y, right? X and y is basically the same as y and x, right? And x or y is the same as y or x. Okay, so this is quite basic. Okay, now the next one, right? Bracket x and y, bracket and z, right? And that is the same as x and y and z, right? So these are the same, right? Similarly, if I have bracket x plus y, bracket, close bracket, plus z, you get x plus y or z. Okay, so x or y or z. Can? Now the next one, right? It looks like it's quite a bit of like algebra, right? X and bracket y or z, right? So what do you have? Basically, it's just like something like your algebra, right, that you learn in secondary school, right? You just have to sort of like multiply it out. The next one, right? X or y and z. Okay, now how do we actually see this, right? So this can be interpreted as x or y and x or z. Okay, right? And let's go to the next one, idempotence. Now, so this is the part that I need everyone to get involved. So the next few, I need the... now, I know that some of you might have a little bit of trouble with this. I'm going to go through that in a short while. But let's talk about number 4, rule number 4, right? X and X. Anyone can tell me how do you simplify this? It's X. Okay. Now, why is it just X? Because if X is a 1, right? If X is a 1, right, then the result 1 and 1 is just a 1. If x is a 0, and 0 is a 0. So basically, the output here just mirrors the x. Okay? How about x or x? Anyone? What x or x? X bar. No, not x bar. Anyone else? X or x? Some more, some more. 2x. Okay. No, it's not 2x. So sorry about telling you guys that it's similar to algebra. It's not. Because this is logic. So x or x is basically just x. Right? So we are looking at inputs, logic inputs. So if x is a 1, right? 1 or 1, okay, we'll just give you 1, okay? And 0 or 0 will give you a 0. So again, it mirrors x. Can Now, if anyone is having trouble, please let me know, right? Please alert me. Because if this part you are not sure or you don't understand, right? Then you're going to have trouble later. Because this a lot of things is going to be built out based on this. So I can spend a bit more time to explain this. Okay, next one, number 5. X and 1. What do you guys think that is? Yes, very good. It's just x. Okay. Now, so here, right, the 1, right, becomes a neutral element, right? The 1 does not affect the output. Okay, x and 1 is just x. So the 1 here, right? It doesn't sort of like it doesn't affect the end result. Okay, how about x or 0? Some of you are getting okay, it is not x, but it's just x. Okay, so now how do I see this? How do I see this? So this is let's imagine this. Now this is the output. So based on this logic function, when x is a 0, the output will be, this will be 0 or 0. So the output will be a 0. If x is a 1, right? If x is a 1, right? 1 or 0, it will be a 1. The output will be a 1. Right? So it actually depends on what x is again. Next word. Dominance. Dominance. X and 0. Anyone can tell me what's the answer? Very good. Well done. Right? Because why? Something and 0 will definitely be a 0. Right? Something and 0 will definitely be a 0. Because for AND gate, right? For an AND gate, you need both inputs to be a 1. Then you can output a 1. Right? If any of the input is a 0, right? I don't care what is this is definitely going to be 0. Right? So in this case, the 0, right, becomes a dominant element. So that's why we call this rule the dominance rule. Okay? Next one. X or 1. Well done. Well done. You guys are prepared. Okay, so because if this is an OR gate, right? Any of the inputs is a 1, then the output is a 1. So again, the 1 here is dominant. Now, so these are the slightly easier ones. Okay, they're a little bit more difficult ones that's going to come out. But no matter what, this is not going to be very, very difficult math. Okay, now, even if you do not understand Boolean algebra, if you are able to apply the rules, right, you can still do pretty much a big part of the Boolean algebra questions, right? Because it is an application of the rules, right? All these rules. So yeah, if you're good with like observing rules and applying them, okay, then this part you should not have too much of a trouble. Okay, now let's take a look at the next one. Negation. Okay, who can tell me x and x bar? What will you give me? Yes, it's going to be 0. Okay, it's going to be a 0. Right, because x and x bar, right, they will always be at opposite logic as each other, right? Example, if x is a 0, x bar is going to be a 1. If x is a 1, x bar is going to be 0. And the output of x and x bar is still going to be 0 regardless of the case. Okay? Now then the next one, x or x bar. Right, what do you guys think it is? Well done, well done. Because x and x bar is going to be opposite. So either one will be a 1, right? So this is equals to a 1. Okay, double negation. Anyone? Well done. Okay, double negation. This is just x. Okay, now the next one that we have is called adsorption. right? Absorption is going to be, now I have X and X or Y, right? So anyone can tell me what will it be? What do you think it will be? X and X or Y? From there. Now, so I think some of you got it already, huh? Okay, go to 0. Now I'm going to give you a truth table for this because if you look at this, right, whatever that you have here, right, is pretty much dependent on what X is. Okay. Right. So if you do the simplification, right, step by step, I'm not going to write the final answer yet. Okay, I'm going to do whatever that you guys are doing first, right? Now, then what can I do here? What can I do here? I can say that is X, agree, right? Because X and X is just X. Now, once I come to this step, right? Once I come to this step, so what do I need to do? Can I say that X is actually X and 1? Can I? So I'm actually applying one of the rules. So you realize that sometimes even if you do not actually know the mechanism behind it, if you just know the rules, you can actually still know how to do this. Okay, now then I'm going to do one step here. Are we good on this? Then after that, I'm going to say, oh, 1 or Y. Okay, 1 or Y. Right, then you can apply one of the rules. You can use rule number 6. Right, then after that, if it's rule number 6, this one becomes X and 1. Then after equals to X. Can Now, I would like to show at this moment, right? Let's say if you are given a question like this, then ask you to simplify, right, until you get the most optimized function. So what do you actually need to do, right? You need to actually show which law you are applying. So example, right? Guys, let's say if you look at all the laws that is already given to you, right? In this particular step, which law did I use? Anyone? Which law did I use? Which rule did I use? Rule number 4. Very good. Now, the numbering that I give here and the numbering I give in the common midterms, I hope I did not mix up the numbers. Right? But don't worry, you don't have to memorize the number because any of these questions that's going to given to you, right, I will straight away put the rule table right by the side. Okay, so you just have to correspond that. Okay. Now, then if you look at it, right, the next step, X, I make it into X and 1. Which rule did I use there? Rule number 5. Okay, so rule number 5 here. Okay, and the next one would be rule number 3, right? Right, then after that, from that step to the next, I'm actually using rule number 6. Okay, then back to rule number 5. Can Quite simple, no, just very simple math. Okay, now, so what do I have here, right? Is basically, this is just equals to X. Now, whatever I have here is the same as this, right? It's the same as this, so this is also equals to X. Okay, now, I'm going to look at the next one, right? Anyone can tell me what the next one is going to be? This is a little bit difficult. This number 10 is going to be a little bit difficult. Equals to 1. What about the rest? Okay, 1 X bar. Okay, now this one not easy. Okay, this one not easy. So for this particular one, right, I'm going to use a very simple way of doing, meaning that I'm going to put X and Y. Right, I'm going to put the X and Y. So there are several ways of doing this. Right, then I'm going to write down what is the output X or X bar and Y. Okay, now I'm going to write 0, 0, right? Did someone get this? Not yet. Okay, not yet. Don't worry. Let's go through this together. Now, look at the table that I have there, right? X, Y. When X is 0, Y is 0, what will be the output? Yes, that's correct. It's a 0. Now, X is a 0, Y is a 1. What will be the output? Yes, it's a 1. Okay, now, anyone need me to explain, just voice out, just voice out. I will go through. Okay, so make sure that you understand this. Okay, how about this? Right, that's correct. Then the last one. Yes. Now, so if you look at it, right, there's more than one way to simplify the functions here, the Boolean algebra here. Okay, now what gate is that? What do you see there? Anyone can, it's an OR gate, right? It's a OR gate, right? Because how do you get an OR gate? OR gate is basically anyone is of the input is a 1, the output is a 1, right? So this is an OR gate between X and Y, right? Now, is there a Boolean algebra way to do this? Yes, there is. Okay, but I feel that using a truth table way to do it is going to be easier. Okay, and out of these rules, right? Now this particular last rule, right, is actually the reverse of rule number 3. So this is actually X or Y and Z. So this is the one that I would like to again use a truth table. There are wait, let me see. Is there a X and X, Y and Z, X and Y, and X? No, let's simplify this using a truth table again. Is it going to look easy with a truth table? Okay, let's try. Okay, so I did not do this beforehand. So let's do this together. Right, X, Y, and Z. Right, so the output of X. Okay, so let's do, maybe everyone can give a try. Sorry, the output of X or Y and X and Z, X or Z. Right now, this is a little bit going to be a bit tedious, but it's okay. Let's spend a little bit of time. Now, I would believe that at the very beginning, right, when all these logic scientists, right, did all this, right, I think they started off with simple Boolean tables like this, truth table like this, and they start work. Okay. Now, so if you look at this, right, if X, Y, Z are all zeros, right? So your output should be a 0. Can? Now, in the second case, right, X and Y are zeros. So this one will definitely be a 0 also. Okay. And the third one, yes, it's going to still be 0. Can? Now, then the next moment when I have, this is 0 and 1. This is 0 and 1. Then this is 0 and 1, right? Then you realize that because it's an OR gate, you only need any of these to be 1, right? Any of these to be a 1, then this portion here will be a 1. Right? So Y is a 1. That's a 1, so output is a 1. Oh, very fast, right? Nitin is very fast. Okay, so what do I have for the next one? This is also going to be a 1. Then this is also going to be a 1, 1, 1. Okay, well done, right? So now the question comes, right? What is the scenario here? What can I simplify this function? So look at now, of course, this is a bit of observation. This is based on a bit of observation. Look at all these ones here. Is this ones dependent on what Y and Z are? No, right? If you look at it, okay, X is a 1, Y and Z, you have all the different combinations for Y and Z, and it does not affect the output. Okay, so that means it only depends on X being a 1. Okay, so that's where you get the first function. Okay, now then we look at the second function. Okay, so in the case that X is a 0 and Y and Z are both 1s, okay, the outputs are 1. Okay, now then let's take a look. You look at this condition. Y is a 1, both are 1s. So we have this situation here, right? That will give me this particular part here. Can? So now besides this 11, okay, we are going to have 2 more, and those 2 are going to be extremely useful, right? So that is going to be called the De Morgan's theorem. Okay, I believe quite a number of you have learned that before, right? In poly, right? So let's take a look at the next one. So, okay, we're good on this, guys. Okay, just in case you need a little bit of time to copy this, maybe I'll give you another few seconds on this. Okay, let's move on already. Let's go to the next segment. Let's go to De Morgan's first. Right, so we have now what kind of gate is this? Anyone still recall? What gate is this? This is a NAND gate. Well done. This is a NAND gate. So this is a NAND gate I'm going to do a very simple thing here. Again, I want to draw a truth table. So, and I want you guys to see what is the output going to be. Right. So this is 0, 0, 0, 1, 1, 0, 1, 1. Oh, yes. Past years, right? There are some students, when they are asked to draw truth table, right? They put it in grayscale, gray code. No, whenever we talk about truth table, please put it in binary sequence. Do not put it in gray code sequence. Hey, do we have someone who got the answer? Let's see. Anyway, let's just do it first. So how does um how does a NAND gate looks like? So it goes this way. Okay, so if I observe these ones, right, I actually see that, so long as either x is a 0 or y is a 0, right, then my output is a 1. Get the logic, guys? So, okay, either x or y is a 0, then output equals to 1. Right now, if you get this, then you can say that, oh, then it must be bar x or bar y. Can Now, on the other hand, the next one that I have is a NOR gate. Okay, so how does a NOR gate looks like? So let's bring this table over here. Right, so this is a NOR gate, and this is going to be 1, 0, 0, 0. Yeah, well done. It's going to be x bar and y bar. Now, how do I actually do this easily, right? So this is how I always like to envisage this. So the entire process is very simple. Split the bar, change the sign. Okay, so I say again, whenever you see an encompassing bar on top, right, then you can do something to the whatever that's below, right? So the first step, split the bar, change the sign. Cannot just two steps. Split the bar, change the sign below. Okay, so if you have something like this, split the bar, change the operator. Okay, so I said wrongly. It's not change the sign. I changed the operator. Right. So what you have here, right? Split this bar, change the operator from N to all. Split, change from all to N. That's it. Okay. So this entire process has been explained in the truth table on the right. Right. So this is going to be now for midterms, right? I'll definitely test you on De Morgan's. Sure have one, and maybe multiple of it. So you got to be very observant. Right. The moment that you see something like this, right, then you have to catch that you can make use of De Morgan's to simplify it. Okay. Now, so what do we have here? I think okay. There are some questions, some examples here actually to be more specific, right? Now, what do I have for this? A and B or A? Okay, so let's take a look at the first one. A and B or A and C, right? What can it be simplified to? So I want you guys to look at the rule table and tell me which one I can apply, which rule I can apply, right? Which rule can I apply here, right, to simplify the first one? Anyone? Rule number 11. Rule number 11, that's for the second one. That's correct. So this one becomes A or B and C. Well done. How about the one before that? Anyone? A and B or A and C? Rule number 9, Rule number 9. Oh, is it rule number 9? I think rule number 3, yeah. I think rule number 9 is a very special case of rule number 3, right? So you have, you can get this A and B or C, Okay, now if I look at the next one, right? If I look at the next one, I can't see anything. I can't see anything that's special here, right? But what I can do here, right, is now so I do not see anything special here. Then what can you do is you can actually sort of like yes, it is equals to A. Yes, it is. But let's do it step by step. The whole process here, right, is for you to work it out until you get the final answer. Okay, but Nitin is quite fast here, right? So what we can do here, right, is take each of these, right? Do it like your your algebra expansion. So we have A and A, then A and B bar, and A and B, and B and B bar. Okay, let's do step by step. So we are just expanding this one, right? So what are we doing here? We are just expanding it out. So this is applying rule number 3. Okay, I think I should put in, right, this is this is rule number 3 here. This is rule number 11, okay? Now anyone can tell me whether any of these terms here, right, I can strike out. I can strike out any of the terms here. Any of the terms here, I can strike out or simplify, right? Yeah, A and A can be simplified to A, right? So later I'm going to write down A and A simplified to A, it will be rule number 4 here, okay? And if I strike out this, B and B bar, right? B and B bar is just a 0, right? And which rule is that? Okay, you can look at, right, B and B bar, this is rule number 7. Okay, so now I have this, right? I have this, okay? Now, there is 2 ways of moving on from this step. I can group these 2 together, right? Or can I actually group these 2 together, right? If I group these 2 together, what would I get? Okay, so I can take it as A and, okay, so can I group these 2 as this? Can? Now, maybe I explain a little bit why I can get to that. Because A can be written as A and 1. Okay, then I can say, oh, then this is A and 1 or B bar. Right, so this becomes A and 1 and get to A. Okay on that? Right, then again, A or A bar. A or A and B. Can? It's the same thing. I can also write this as A. I can also write this as A and 1 or A and B. Right? Then from there, I can sort of like factorize this. Then I get back to A and 1 and then A. Okay, so this is which one? A. So rule number 6. Is it rule number 6? Yes, rule number 6, that's correct. Okay, so you need to apply rule number 6 twice. Okay, guys. So next one. How about the next one? Okay, so I'm going to factorize again. Okay, so this one is rule number 3, right? Then after that, I'm going to say, oh, what is B or B bar? It's just 1, yeah? So that is going to be under rule number 7. Then after that, this is going to be equals to 8, rule number 6. At rule number 5, sorry. Can? Oh, I think this is rule number 5 as well. This is rule number 5. Can? Which one? Rule number 11 to directly get to A and A bar. Rule number 11, yes, you can. You can. To get to, for which one? Can we use to directly get rule number 11, you can. Right, but I wanted to show you how to use all the different rules. Right, you are right. Okay, you can actually use rule number 11 directly. You get the same answer. Can? Okay, it's good. It's a very good observation. Right. So if you look at it, right, some of the rules, right, might like there's an overlap, and you can actually use a longer path to show. So basically, what I wanted to show here, right, is how you can expand term by term if you cannot identify whether there are any superlative rule or law that you can use. You can always use the lower level ones to help you, right? Or even truth table. Can? Okay, so let's move on from here. We have some examples. I'm not going to do all of them, but I'm going to pick a few, right? I'm going to pick a few to work on it. Then let me see. Which one looks interesting? Okay, so let's go to the next page. Which one? I'm not going to do this. This one, please try on your own. Try on your own. Do I want to do this one? I think this one is a little bit boring. You can, but there is some things that we need to. Would it be better to apply now? If you can see the rules, then you apply it straight away. Okay? If you can see the rules straight away, use it, right? Then you don't really need to expand if you can see that there's a pattern. But if you cannot see the pattern, then expand it up. Can? So there is no hard and fast rule on solving Boolean algebra functions. Okay, so you have to understand that you can go many ways. So example, during the midterms, right, got 1 year. So there was a quite complicated Boolean function. Some students were able to do it within maybe 4 or 5 steps, right? Then some students need about 10 steps. Okay, it's fine. So long as you get the answer and you get the mark. Okay, so it doesn't matter, So but what you say is right. If you can observe the rule immediately, you don't have to expand it. Okay, but if you cannot observe or you couldn't see anything, then expand it for you to be able to see it better. Now, so the next one that I want to do, right, is again, okay, I just want to show that process of doing and writing out the rule, what rule you use, and so on and so forth. So the first case, let's take a look at this one. I have A and B, or B and C and B, B and C and C. Okay, right? So what did I do? I actually distribute up. I use rule number 3. Now, what is the next step? Now, the next step, you can do this, or you can omit this step if you want to. All right, this is not totally necessary. Okay. Now, the next step, I'm going to make use of rule number 4. Right, rule number 4. Now, rule number 4 is when you have two identical inputs, right? You can simplify it like this. Okay. And again, there are two similar inputs. Okay, this is again rule number 4, right? Okay, and you factorize. Now you can leave it as this form, or you can factorize it. Both accepted, but if you factorize it, you are using rule number 3. Okay. Okay, this is the one that is okay. Now I should have chosen one that will give you a more elegant answer, but I just wanted to give you one that you can practice using more rules in that process. Okay. Now, now let's take a look at this. This is like so crazy, right? So many things inside, right? But what do you observe here? Which rule can you use here? Anyone? De Morgan's, that's correct. Now, so what will happen here, right, is now some students ask, should I work from inside here, then outside, or then outside here, or inside, the kind of thing, right? So up to you. You can actually do, now listen, in fact, you can do like 2 or 3 things in one step if you want to. That's fine with me. But you must state clearly what rule you use. Now, but again, for clarity's sake, I will still show step by step. Now, so what do I see here, right, is I see the negation here, and I see 2 terms beneath it. Oh yes, De Morgan's, you can also apply for 3 terms. Okay, 3 terms or whatever number of terms still can apply. Okay, so we are going to treat this as 1 term and treat this as 1 term. So you can see that I can break and change, right? Now, this may not be the most efficient, but I'm just trying to show you all the different ways of doing things. So now the top bar, okay, I break into 2. I change the operator from all to n. So I will have this, okay? I have D, okay, and I applied rule number 12, which is De Morgan's. Okay, guys, what can I do next? What can I do next? Which rule can I use now? Remove the bars, correct? Now, but let's take a look at this part here. Can you see a double negation? Right. If you look at the double negation, right? So I can apply rule number 8. Now, when you apply rule number 8, this is something that you got to be very, very careful. This is, again, the most common mistake that students make. Okay? This is wrong, right? When you remove this bar, right? Actually, this is considered as 1 term, right? So when you remove this bar because of rule number 8, right? You applied rule number 8. Don't forget, this is still inside a bracket. Okay, now, but I think I do not want to waste that step. I'm going to do something to the one on the right as well. So I'm going to do something here. Okay, now there are 2 things that you can do here, right? There are 2 things that you can do here. So I'm going to split using De Morgan again, right? Because I do see that predominantly there's two elements, right? Two components below this, below the bar here, below the bar here. So I'm going to split the bar again and change the operator. Okay, and what did I do here? I applied De Morgan's for the second part. Now see how I can do two things in one step so that I can reduce the number of steps. So if you are operating on two different parts of the logic function, right, it is perfectly fine to operate simultaneously. Okay, so we are good on this. So the next step that I have, I have to continue from here. I can't do anything to this yet, but you realize that on the right, you can still simplify further, right? Now with that double negation, I can remove it. Okay, and rightfully, I should be writing it this way because this is going to be E or F bar. Okay, so again, what I did was I used double negation. Okay, so then it will be A or this. There is no difference because this is OR, so I can actually make use of the next rule, which is let me see, rule number 2, to just open this up. Okay, then the next step, you realize that there is nothing here, that you can see common, right? So then you have to expand out term by term, and you should get 6 terms in total. Okay, are we good on this? Okay, so we are done with this question. So now, I think I just want to do one more example, and I'll leave you guys to do the remaining ones. Okay, so let's do one more example. Right now, anyone needs the working, you can let me know. Right, if anyone needs the working over here, you can let me know. Right, then I can post on Excite. If no, if you guys don't need, then that's fine. I'll just leave it to you because the answer is already there. Can? Right, so let's move on from here. Okay, which one do I want to do here? Yeah, I think I want to do this one. Right, so this one, please try on your own. Right, I think this one has quite a bit of things that we have tried before already. Okay, so let's work on, right, let's work on the one below here. Okay, so if I observe, right, there is actually nothing much I can do at this particular step. So I can do this. Now, can you see the B bar here? The first term has a B bar here. The second term has a B bar here. Okay, so I'm going to do this. I'm going to do B bar and C and okay, then I'm going to be left with A and C or okay, I'm going to do something here. I'm going to okay, let's see. Okay, are we good on this? Right? Are we good on this? Take a look. Now, there are some steps that I can use in between, but let me ask a question here. Is there one way to speed up the entire process? Anyone? Okay, it's okay. Let's just do it. Okay, but there is one way to speed up. Which one? Use rule number 12 for BD. Yes, we can use rule number 12. But if anyone can see that you can use one of the rules. Okay, now my initial intention is for you to use rule number 12 and move on, right? But for some of you who is a little bit who want to challenge yourself, see whether you can find anything that can shorten the step. But we are just going to do rule number 12 first, okay? So we're going to do De Morgan's, right? So B and C and now let's split that up. We will have A and C or A and I'm going to split that up already. Okay, so we have this thing here. Then let's continue. Okay, anyone can see something? Anyone? Rule number 3. Rule number 3 is, how does rule number 3? Or distribute up. Okay, let's distribute up. Okay, so we have A and C, or A and B, or A and D bar, and A bar. Okay? Okay, so what's next? Rule number 10. Okay, someone said rule number 10. How do I use rule number 10 here? Anyone? Okay, what is rule number 10? Rule number 10 says this. Okay, X or X bar and Y is X or Y. Can I change rule number 10 to suit my usage? Can I do that? Can I change it to X bar? Right? Can I actually do this? I change X to X bar. X bar becomes X. Can I do that? Okay, so then I get to this particular form. Okay, so what do I have here? Right, so I will have B bar and C, and now whatever that I have, let's see, which one can I, okay, let's see, let's do for these two, can? Let's do for these two, so I will have A and C, right? Then I will have, okay, this will become A bar and B bar. Okay, can, guys, are we okay on this? Okay, let me see. Did I miss out any steps? I should be able to get up to that final step already. Okay, let's see. A and C, or B and D, or A bar. So A and C, A and B, D. Okay. Okay, I think I missed one step. Can I apply rule number 10 again, guys? Right, can I apply again? Rule number 10. Okay, let's apply rule number 10. After I apply rule number 10, what do I get? Okay, so if I apply rule number 10, right? Can I actually get A or A bar or D bar? Can? Okay, bracket inside will be A bar or C, right? A bar or C, or B bar or D bar. Okay, I think there is something missing, right? Okay, did I miss out anything? Let's see, okay, let's see. A and, okay, I think I missed out something, did I? Okay, never mind, guys. Let me take a look at this. Okay, but finally you should get B and C. You should finally get a B and C. Okay, let me check. Let me check out this. I think there's one step that let's see. I just want to check for a while. I took out B bar here, C, right? I open up and apply De Morgan's. Okay, let me take a look. Let me take a look at this. I'll come back to this. Okay, I'll come back to this in a while. Okay, now let's continue to the next page. Now, there is two questions for you to practice on this page, right? There's
Prof,
two.
just curious. Prof, just curious. The answer for that, right? You say the answer should be B bar and C, right? Then what about D bar? What will happen to D bar? Cause there's no way D bar can be cancelled out, right? There's no normal D.
No, okay, so rightfully, I should be able to get something like this. So this will becomes 1, okay? This will become 1. So you don't have to care about the D bar.
Okay.
Okay, let me sort out on this. I think I missed out something here. Okay, so let me take a look at this. I'll get back to you guys. Okay. Now, what I want to do now, right, is on simplifying logic, right? Not by Boolean algebra, but by observing from truth table. Okay. So now what I want to do here, right, is, okay, let's go to this page here. Okay, so when we actually have a lot of logic gates in between, right, to form your Boolean algebra functions, right? Right, in actual fact, there are actually going to be propagation delay. Example, okay, example, if I have, right, maybe a situation that looks like this, right? Maybe I have a situation that looks like this, right? Then I have a situation that goes on something like this. Then I go to an OR gate or something like, so this is, maybe this is going to be, right? Now, each gate, right, you will take some time to process, right, the signal, right? So there will be something called the propagation delay. Example, maybe each of the gate here, right, take maybe 2 nanoseconds or something like that. Right, this is 2 nanoseconds, maybe 2 nanoseconds, right? Something like this, right? Then there will be propagation delay along the way. Okay, there will be propagation delay along the way. Yeah. Now, so this propagation delay, right? We actually use something called a time delay, which we use the Greek alphabet tau, okay, to define it, right? So this is the moment that we have circuits whereby you have many gates, one after the other, many stages, then you're going to have propagation delay and stuff like that. Now, will all this timing, right, when they come together, right, it will add on to the total processing time. And sometimes it will affect like the how much gates, some output might be ready before other output, okay? And some new input might be changing, right, that will affect the output. So you will have to be careful about the timing consideration and stuff like that. Now, that part, right, we'll be talking about during chapter 4, right? But for now, we are only going to focus on combinatorial circuits. So combinatorial circuits is basically just gates, okay, just gates. So let's take a look at okay, how do we actually come up with the truth table, okay? And then from truth table, come up with the Boolean function. So let's talk about some basic terms here first. Number one, we call a mean term, right? What is a mean term, right? A mean term is a Boolean expression that results in a 1, output 1, okay? And it's written as, right, small m I, okay? Then we can also define the max term. And max term is a Boolean expression that results in a 0, right? And that will be big M and I. Okay? Now, some of these forms, right? Some of the terms that I'm going to talk about here, right? It will take some time for you to understand, right? To know the terms exactly. But for now, I'm just going to go through this first. Then later when we come to a truth table, then we're going to talk about how we can make use of these terms. Okay, so number one is sum of product. Number two, product of sums. Okay, now when we talk about sum of product, right? Okay, is the OR of the mean terms, and the product of sum is the N of the max terms. Okay, now at this point, don't worry about these terms first. I'm going to go through an example, and I think you'll be able to understand what is sum of product and what is product of sum. Okay, so I'm going to go through the first table first. Let's take a look at the first table. Okay, now the first table is, okay, A bar, B bar, and C bar. Okay, so A bar, B bar, and C bar. So that is, how do you get a 1 for that? Anyone? How do you get a 1 for A bar, and B bar, and C bar? You need, what are the inputs for A and B and C for you to get a 1? Anyone? All zeros, very good. So you need 0 and 0 and 0. So that is what we call the mean term M0. Can? Now next one. How do I get a 1 from the next Boolean function, A bar, B bar, and C? Right? So A, B, C needs to be? Yes, very good. So 0 and 0, 0, 0, 1. Right. So then that will be the mean term M1. Okay. And then the next one will be 0 and 1 and 0. This is mean term 2. Now, so what we are doing is we are actually like giving a name to each of these of each of these products, which will appear in my truth table. Okay. Now then, eventually we are going to make use of the numbering rather than the inputs. Okay. So we are going to complete this table first. Right. This is going to be M6, then M7. Right. Okay. So now on the other hand, right, we are going to invert M0, right? We're going to invert M0. So you are going to get bar of bar A, bar B, and bar C, right? Then I'm going to apply De Morgan's. I'm going to apply De Morgan's here, and I'll get A or B or C. Okay. Now when I apply A or B and C, so A, B, and C, so for this particular term, okay, the bar M0 is going to be A or B or C. Okay, so I'm going to write down, this is my M0, big M0, big M1, big M2, big M3, big M4, big M5, big M6, big M7. Now, this part that we are writing down, right, you might not understand immediately, but in a short while, we're going to talk about what is happening. Okay, I just need you to fill up the blank here first, right? Then later, I'm going to explain to you what is going on. Okay, let's just look at the table on the next page. Okay, just look at the table on the next page. Then we are going to do the first example. Now, at this point of time, the big M0, big M1, all the way to big M7, okay, it will not look apparent to you. Okay, but after we go through the first example, right, it's going to be a little bit more apparent. Okay, so fill up the table first. We do one example. After that one example, okay, then we're going to take a short break. Okay, let's move on. Let's move on. Now, so this is a truth table that I have, right? So I want everyone to observe this truth table. Okay, then we are going to do this. We're going to say, hey, let's look at this truth table and come up with the Boolean function. Okay, let's come up with the Boolean function, right? Without simplification, no simplification. Okay, just whatever that is in the truth table, let's come up with the Boolean function. So I'm going to look at the first one here. Okay, all these that I'm going to have here. Okay, so, right, let's take a look at the first one. How do I define the first one here? Right, anyone? How do I define the first one here? It is a one if, no, do not group. We are only looking at that particular row. Right, anyone? How do I get a one? How do I get a one for that row? Yes, very good. So you need to have A bar and B bar and C bar. Can Now, I want you to now look back at the previous table. Can you see that this one corresponds to this particular case and is defined by the mean term M0? Okay, so we are going to go back to this and look at this particular segment here. Okay, so which term is this? Which mean term is this? This is mean term 0. So I'm going to put 0 here. Can So instead of writing A bar and B bar and C, right, I can say, oh, this is a mean term 0. Okay, I hope you are getting this. So the next one that I have is this is M1, right? And M1, how do I get M1? I have A bar and B bar and C. Okay, and that corresponds to, okay, and I have another 3 more to go, right? The green one, this is M2, right? So I'm going to add one more, which is M2, and that would be, let's see, this would be A bar and B and C bar. Right, then I'm going to do the next one. Okay, I'm going to use another color here. Let's use purple. So this is M3. So on the right, that would be M3, and M3 would be A bar and B and C. Okay, and the last one, right, let's change another color. Let's use yellow. Right, this is going to be M6, right? And M6 is going to be A and B and C bar. And here you write 6. Okay, now, so this is how you come up with the sum of product. Okay, this is the sum of product. So this is what we call, this entire row is what we call the sum of product, okay, of the Boolean function. Can I? Now, listen here, can I get all of you to try for the next one for G? And you are supposed to fill up over here, right? The sum of product. Okay, so we are going to circle the one that gives you a 1. Can I? So this is going to be M0, M1, 2, 3, M4, M5, M6, M7. So I'm going to write here 0, 3, 4, 5, 6, and 7. Right? And each of these, I'm going to write down the Boolean function of the respective terms. Okay, we have A and B and C bar, and A and B and C. Okay? Now, so whatever we are doing here, right, it's just no simplification. Totally no simplification. We come up with the most basic or most primitive form. Okay? Okay, so this is again the sum of product. Right? Why do we call it the sum of product? Within each one, right, this is a product, right? Then this is a sum. Okay, same for the other one. Right? So how do we write this, right? Sum of the mean term, right? Then we put all the mean terms in between here. Okay, so this is the sum of product. Okay, so we're going to go for a short break. Come back, we are going to discuss product of sums. Okay, so guys, let's go for a 5-minute break. Now the time is 10:15. So please come back at 10:20. Then we're going to resume we're going to talk about product of sums. Okay, right, see you guys in a while. Okay, hi guys, welcome back. Right, now we are going to continue on getting the product of sums, right? So we are going to look at the zeros now. Now, so I want to just go through this little exercise for you guys to see what is actually product of sum. Right now, I need everyone to focus on this part because this can get very, very confusing. So I need everyone to focus here. Now, I need you guys to look at the rows that will give me the zeros. Okay, can you see these 3 rows, right? So when I'm looking at the zeros, I'm actually looking at the F bar, right? I'm looking at the F bar, right? Can anyone tell me what row, the index row number 4, row number 4, what would the inputs be to get a 0? Anyone? That's correct. A and, so it'll be A and B bar and C bar. Okay, and we also have row number 5, which is A and B bar and C. Right, and we have also row number 7, which is A and B and C. Can So this is as per normal, what we have been doing so far. But now I'm not interested in F bar, right? 420, 320. What is 420 and 320? M3, M2. It's not. It's not. Okay, wait first. So what I need y'all to do now, right, is I want to get F first. I want to get F first. Wait first. You guys are 2 steps ahead. No. Wait. Okay. So let's go to F first. How do I get F? I will need to invert the other side. Okay. So I have to invert here. Now I need you to observe already. Pay attention here. Very, very important. I want you to see for yourself how I evolve. I do not want this. This function is too complicated. Can I apply De Morgan's theorem here? Okay, so I'm going to apply De Morgan's theorem, right? So it's going to be, sorry, I should have added a little bit more space here because I'm going to show this, right? Yeah, but I did not account for that space. So try to squeeze in a little bit. Now, remember that if I do De Morgan's, it will become like this. So you will have A, B bar, and C bar, A, B bar, and C, A, and B, and C. Are we good on this? Now, what is important is the next step, right? Do you see that it will become De Morgan's again? Okay, guys, do you see this? Right. So the F function can also be defined by a product of 3 sums here. Okay, and how do you observe the sums? Okay, it will be This will be A bar or B or C. Okay, A bar or B or C bar, and A bar and B bar and C bar. Okay, now it is not M3, 2, and 0. This is big M 4, big M5, and big M7. Okay, you can refer to the previous page, right? That these three terms that we have here, right? Refer, is this one. Okay, this one and this one. Okay, so it's 4, 5, and 7. So here 4, 5, and 7. Now this is confusing. Okay, so when we ask for the POS form, right, it's not so simple. Now, how do I write the POS form, right? This is a pi. The pi stands for product of the max terms 4, 5, and 7. Okay, now at this point, I think you might get a little bit of it doesn't seem so easy, right? But I'm going to teach you one technique. So now I'm going to look at the next example here, and let's come up with some simple rules here. Now, what do you see here? If I want the product of sums, look, I want you guys to observe this, observe this, and observe this particular one. Can you see? What do you observe? Guys, what do you observe? Right? What do you observe? Opposite, very good, right? So I just need to do this. When I'm looking at the zeros, when I'm looking for the zeros or the max terms, right? Whatever I need to do here, right, is just that I will have to invert the inputs when I place it inside the function. Okay? Okay, let's just do one example. Let's just do one example to get this concept in. We are going to do the function g, right? So let's take a look at the two rows that will give me an output of 0. So one of them is this, and this is big one, M1, and this is big M2. Let's use two different color for this. Now for the M1, right? A is a 0, B is a 0, C is a 1. Okay, but because I want the product of sum, I have to invert all the inputs. So it will be A bar, because A is a 0, so I have to invert it to become A. B is a 0, then B, I invert it. C is a 1, I invert it, becomes C bar. Okay, so it's opposite. So for product of sum, it is opposite. Now, how about M2? M2, input A is a 0, invert it. Input B is a 1, so invert it becomes B bar. Input C is a 0, invert it is a C. Can? So this is the part that is a little bit confusing. Okay, and how do I write it in this particular form? Product of all the max terms, you just need to write M1 and M2. So 1 and 2. Okay, guys, are we good on this? Are we good on this? This is going to be confusing, right? But once you get used to it, right, or once you practice enough, right, this is actually quite routine, right? So there are two ways of writing this. So there's two ways of writing this. This is the sum of product form. This is the product of sum form. Product of sum form, sum of product form. Okay, and sum of product is also called the disjunctive normal form. This is called the conjunctive normal form. Okay, but don't worry about the name. Don't worry about the name. If I do give you like disjunctive, right, normal form, then I will put a bracket, sum of product. Okay, question, is it wrong to think that for SOPA, sum of product A is 1 and for A is product of sum A, product of sum A is 0. Product of sum A is 0. Okay, because when we are looking at product of sum, we are actually defining the function using the 0. We are defining f bar. Then from f bar, then we do De Morgan's. I hope you understand what I'm saying. So what's the difference between the two examples is just to illustrate. The two examples, right, is just to illustrate the sum and product and product sum. We are doing both for both functions, both examples. Okay. Now, don't worry, there will be ample situations or questions whereby we will let you practice on this. Now, I want to move on to the next page already. I think on the next two pages, right, there's a lot of practice for you. Okay, so don't worry. Now, I want to introduce this table here, right? Now, so this table here, right, got 3 crosses, right? Now, that 3 crosses is what we call the don't care situation, okay? Now, when we have a don't care condition, right, it can refer to input combinations that never occur, or it can also be whereby the output will not change, or it is not going to be affected by those input, okay? So we call these are the don't care condition. Okay, now, so when it's a don't care condition, right? Okay, it can be a 1, it can be a 0 for the output. It does not matter. Can? Now, so it helps us do a lot of things. The don't care situation actually help us to simplify our functions a lot. But before I continue, can I get you guys to just fill up this for me? Fill up this for me. Right? Now, then the D, right, stands for don't care. Small d when it is the sum of product form, big D is product of sum form, and the difference, this is a or, this is an and, right? So can I get you guys to fill in this for this particular one first? What do you fill in here and here by observing the table? Can we? Okay, anyone? Summation of M, what should you fill in inside that? 1, 2, and 7. Oh, well done. This is 1, 2, and 7. Okay, very good. And for the don't care, what do you fill in? Yep, that's correct. Okay, how about product of sums? So when we look at product of sums, we look at the zeros. Okay, so what would it be? 0 and 3. And the don't cares will just be 4, 5, and 6. Can? Now, let's practice on some examples. Okay, I think we have, yeah, we have one example on the next page. Okay, let's take a look at this. Right, we are now, if you look at these two, right, these two are exactly the same. These two are exactly the same, right? 0, 1, 1, 0, 1, 0, 0, 1, 0, 1, 1, 0, 1, 0, 0, 1. They are exactly the same. It's just that for the first form, I want the sum of product, and for the second one, I need product of the first one is sum of product, the second one is product of sum, right? Now, so I'm going to do the first one. So this is going to be okay. Now then I'm going to get this one is A bar. This is easy, right? Then we have A and B bar and C bar, and this A and B and C. Okay. Now so draw a line here. Draw a line here. Okay. Now then I can just write. This is the sum of product. Okay, now I'm going to look at the product of sums. Now, how do you do the product of sums? Very, very simple. So, okay, just a little bit confusing, but it's the step is simple, right? So it will be the product of individual terms. So it'll be bracket n, and bracket n. So what you need to do is you look at the input that you have, you invert your inputs. Now you look at those that give you zeros, when we are looking for product of sum. So the first one will be A or B or C. Understand? Because A needs to be a 0, B needs to be a 0, C needs to be a 0. Okay, we will have to invert the inputs. Okay, so the first term is A or B or C. Second term, 0, 1, 1, invert. So you get A or B bar or C bar. Okay, and the third one, A bar or B or C bar. Okay, invert A bar or B bar or C. Okay, so let's fill in the blanks here. Okay, if you manage to do this on your own, right, then I think you got the concepts. Now, just for those of you who want to convince yourself that this is actually correct, right? So what we are going to do here, right, is now you drew a line here. So this actually belongs for this part. In order to get the Z bar, right, based on the sum of product, right, I will have A bar, B bar, and C bar. Okay, A bar, B, and C. A, B bar, and C. Then A, B, and C bar. Right? So from here, if I find Z, which I do, De Morgan's of whatever I have there, I will be able to get exactly, right? If I do a De Morgan's of this, I will get the function on the right, which is the sum of product. So I say again, the product of sum. So this is sum of product. This is based on product of sum. Okay, question? This is equals to this. It will give you exactly the same results. So because whatever I did here, right, is based on the zero, so it's z bar, correct? That which we went through this before. Then from there, I do De Morgan's. I invert first, then I do De Morgan's. I get this form. So they are exactly the same. Can I? Now I would like to spend some time to go back to the question that I was stuck just now. Okay, I think I did a stupid thing just now. Okay, I should not have taken out the B bar and the C bar because it helps me. Yeah, question. Is it like this? Question? Anything? Oh, you finished already? Good. I did a stupid thing in that I go and factorize the thing out, right? Yes. This is what I want to do. Okay, so I did a stupid thing in bringing out the B bar and C. And because of that, I couldn't simplify the thing inside. And I keep looking at the thing inside. Okay, so you need the B and C to help you get rid of some stuff. Okay, right? Anything well done, huh? So I was just focusing so much on the inside, and I forgot that these and these are replicates, and this is replicate, which you can remove. So what happens here, right, is that at this particular step, now rightfully I shouldn't do the factorization. I should expand in first because it actually helps me to get rid of some of the terms. Now, so if I multiply this out, right, then I can actually get this. I can get we just imagine, guys, imagine B bar and C and A, right? So you can actually just do this. I hope you guys see what I'm doing here. Yeah, this is a very stupid step that I made just now. Right? So I keep focusing on the inside and I forgot about the outside. Okay, now once you come to this step, right, then you can see that this is basically just B and C and 1, right? Because I have A and A bar. These two, regardless of the situation, right, is going to be, one of them will definitely be a 1. When A is 0, A bar will be a 1. When A is a 1, A bar will be a 0, right? Okay, and because these are all terms, you actually get a 1 or A and D bar. I think someone mentioned about what happens to the D bar just now. Okay, it will be absorbed by the 1. Okay, 1 will settle everything because 1 or something is always 1. So you get back to this and then you get back to this. Okay, I made a very silly mistake. I actually go and factorize it out, which I shouldn't have. Okay, so sometimes you can get into this kind of mental block. Okay, so yeah, so if you look at it, sometimes it might be easier to also look beyond or outside the box. Okay, so when you look outside, then you realize, oh, the C and C can combine. Then the B bar and B bar can combine. Okay, guys. Okay, on this we have to move on. I'm quite behind time. I'm quite behind time. So let's go to now. The moment that you have sum of product and product of sums, right? Then what you can do, right, is that you can combine into circuits. Right? Now, why do I want to do product and sum and product and not simplify it? Because you can actually make it into, okay, array circuits like this. Guys, understand what I'm trying to do here? Because the moment that you have everything in that nice form, without simplification, right? You can actually get computers or even programmable gates, right, to program things for you nicely. Okay, like this. Okay, but when you want to customize something, right? Last time you of course need human beings to optimize the logic or whatever. Okay, so but during those time whereby let's say if I want a circuit that a hardware that can be optimized, that can be you can change the program inside. Then you need something that has some standard features like this. Okay, take a look at this. So if I have a sum of product form, then what do I need to have is I will need 1, 2, 3, 4 AND gates. 4 AND gates. followed by one OR gate. Okay, then I can implement this function, right? Then in the other case of the product of sum, then I will just need 4 OR gates followed by one AND gate. Both will do the work. Now, so what do I do here? Now, I'm going to just draw the SOP one, right? You can do the POS one by yourself, or maybe I'll just show one connection, okay? Right, so what's going to happen here is you will need the A and the A bar, okay? You'll need A and A bar. Now, I think I do not want to draw it like that. I want to draw this way. I think it's going to be easier to see. I'm going to draw A. Then I'm going to draw one line all the way down. So forget about the A and B and C over there. Right, guys, can you erase that? Right. Okay, I realize that it's easier. I think it's easier to see this way. A lot of students feel that it's easier to see this way. Then I draw all the line all the way down. Then I draw my B, draw one line all the way down. Then B bar this way, all the way down. Same thing, C all the way down, then C bar all the way down. Now take note, when I have two lines crossing over each other, right, there is no connection. Okay, how to make a connection? Please put a dot. Then there is a connection. Okay, so what do I have here, right, is in order to implement the first term, right, the first term, the first mean term here, I will need A bar and B bar and C, right? So I will need to draw here A bar, A bar, put a connection there, B bar, put a connection, then C, put a connection. Okay, so this is how, okay, this is how you work on the connections here. Then second one will be A bar, so A bar, make a connection, go over. B will be here, then C bar, right? Same, and I will have A for the first one, B bar for the second one, C bar for the third one, then A, B, C for the last one. Can So you are done with the circuit, right? So for the POS, similar way of doing. Okay, so similar way of doing, right? So maybe I will draw for, okay, so you need 6 lines, put the invert, then all the way down, right? 6, then put the invert all the way down. Okay, all the way down. Okay, I'm going to do for the last one. I'm going to do for the last one. The rest, please do your right. A bar, go to the first input. B bar, go to the second input. C, go to the third input. So on and so forth. Okay, any questions on this, guys? Okay, so SOP, POS, right? Okay, I want to start a little bit on Karnaugh map. Okay, let's go to the Karnaugh map. Now this one, I'm not going to spend the time doing this. This is just to prove how you prove from SOP to POS using a direct application, a direct conversion, not the De Morgan's way. So I do not want to spend time on this. Okay, so you guys can try it on your own time. Now the next important part, okay, extensively tested in midterms will be K-map, Karnaugh map. Okay, now so what is Karnaugh map? Karnaugh map is actually putting your truth table into a gray code form. Okay, whereby everything that is beside each square, right, beside it, there is only one bit change. Okay, now, so simple thing, this is the truth table and this is the K-map. Let's fill in based on the input here. So we are going to do this. A and B are 0, 0, 0, 0, the output is a 0. Okay, let's go to the next one. A is 0, B is 1, A is 0, B is 1 here. This is a 0. Next, A is 1, B is 0 here, is a 0. Then A is 1, B is 1. The output is a 1, put a 1 here. So this is a K-map. Now, listen here. I'm not going to talk about this first. Okay, I'm not going to talk about this first. These are the rules and steps. I want to straight away use an example and show you. So we are going to do this. And I'm going to wait, let's see. Okay, so I just, let me fill up this page first. So Karnaugh map, right? We actually use it for 3 to 4 functions, sometimes up to 5, but not practical to use for up to 6 input. 6 input it will not be practical. Now, I want everyone to look at the K-map here. Spot something that I want you guys to see. Can you all see something here that looks different? Yeah, this is based on gray code. Can you see this? Right? Can you see 0, 0, 0, 1, 1, 1, then 1, 0, right? So 0, 0, 0, 1, 1, 1, 1. Now, what is the trouble here? When you are trying to fill your Karnaugh map from the truth table, you need to do something. You need to be very aware that this particular column has been displaced, right? So you do this. So I always tell my students, when you fill up, right, you do this. Pay special attention to that row and that column. Okay, so I'm going to show you how to do a simple, right? How do I fill in the table here? We're going to do a 3 input. Okay, then we are again going to look at this 3 input. I'm going to shade this box so that I'm aware of. Okay, so this is based on the not optimized SOP. I'm going to write down the not optimized SOP. Right, this is the not optimized one. This is just list up everything that you see, not optimized. Okay, now we are just going to do this example, then we'll get end already. So please pay attention. This one very important. Okay, so how do I feel? Okay, so this one is 0, 0, 0 correspond to this, 0, 0, 1 correspond to this, and the output is 0 and 1. Let's fill in. Next, 0, 1, 0, 0, 1, 1. 0, 1, 0, 0, 1, 1, and this is 1, 0. Can the next one, can you see the blue box? The blue box means skip it first. Skip it first because this is gray code, but the truth table is not gray code, right? So now we go to this. We go to 1, 0, 0, 1, 0, 1, and that is in the last column. 1, 0, 0 here, 1, 0, 1 here. So it will be 2 zeros here. It will be this 0 and this 0. Can? Now then I have 1, 1, 0, which is a 1, 1, 1, 1, which is a 1. So these two will be 1s. Okay, now once you're done with that, then I'm going to erase this. Okay, now I'm going to show you, without telling you the rules, I'm going to show you, right, how do we simplify this function. And when you get the most optimized on truth date on the K-map, it is the most simplified. I'm going to look at the first one. Okay, guys, look at the first one that I loop. Can you guys tell me what that function is? What function represents that 2, 1 over there? What does it depend on? Does it depend on A? Look, does it depend on A? Can you all see that it does not depend on A? A can be 0 or 1. Both are still 1. Can you all see that? Okay, and can you see that B must be a 1, right? So, but you also need C to be a 0. Someone got it already, right? Jordan got it already. So the first one that you see here, this is B and C bar. You will need some time. If you cannot get this at one first shot, it's okay. It's okay. Don't beat yourself up. Can? Now I'm going to do one more. Right? Look at this. Anyone can tell me what this is? Straight away, anyone? Yes, well done. A and B. That's good. Now, so look at this. I go for the ones that I can group first. Now I can only group what? I can only group in terms of 1, 2, 4, 8, 16. And it must be rectangles or squares. It cannot be some funny shape. It must be rectangles or squares. Okay? So now I still have one left. And that one is a loner. Got only one on its own. Okay, so can anyone tell me what that logic function is this? Anyone? No, not so simple, this one. It should be a 3 input. Because that one, you need A bar, A to be A bar, B bar, and C. Well done. Okay, so this is A bar, B bar, and C. Okay, so what do I have here, right? It's 3 terms here, A and B and C bar, then A bar and B bar and C. Okay, guys, we have to end the lecture already because I have a 11 o'clock lecture coming up. Okay, so this is a good point to end, but I am a little bit behind time. Now, if I do want to, I might be doing a recording. Let me check my timing first. If I find that I need to push some of the materials forward, I might need to do a recording. I will let you guys know. If I do a recording, I will make an announcement. I will see how much time I have behind. Can so right. Okay, so I believe you can start doing parts of 2A and maybe 2B. Okay, maybe you can do a bit of 2B already, right? So again, for tutorial this week, we are going to have a quiz. The quiz number 1. I feel it's pretty okay, the quiz. Okay, so again, I will be providing writing paper for you to do your working, right? So bring your laptop, Ken. Okay, guys, thank you for attending. I will see you guys on Friday for tutorial and your quiz.